Hello, I'm Yuki Hanyu, the founder CEO of IntegriCulture company. The company is also a spin-off from a citizen science community of open source DIY cultured meat. I got into this field because cell cultured meat and cell agriculture has been a common topic in science fiction, anime, and manga. The pictures on the right is what I drew. The top is microalgae and animal cell culture vertical complex, and the bottom is a scene from ubiquitous cellular agriculture in a solar punk style, where you see those bioreactors attached to those ecologies. So the IntegriCulture company, as a spin-off, takes the physical infrastructure part of the original vision formed at the Shoujo Meat project in the initial phases. So the vision and spirit is inherited from there, and the company aims to build an universally accessible cellular agriculture infrastructure for rapid rollout of cellular agriculture. So in this kind of world, the technology of cell culture has been used in different scenes, such as for food production, of course, but for cosmetics or entertainment, or to make cell cultured fur, like restaurant chefs designing new meat, and it could be used for medical applications as well. So the cell cultured meat, as probably most of you know, it's made from animal cells, it's real meat. But at the same time, we know the technological difficulty of them being very, very expensive. And mostly, again, as you know, mostly due to expensive growth factors and high capital expenditure for bioreactors. So for the solution part, there has been different approaches to tackle this growth factor problem. One is for the use of fermenter or plant or insect extraction from a genetically modified or gene edited and plants or insects. But it has got a problem of expensive extraction and purification processes, as well as difficulties on non-peptide products. The other approach is the use of conditioned medium produced by co-culture of different cells. The drawback is the conditioned medium is chemically undefined, which is a drawback for pharmaceutical applications, but may not be for food. And arguably, it is tricky to control. The CulNet system developed by IntegriCulture company is based on this co-culture approach. So in this CulNet system, which consists of target cell bioreactor and feeder bioreactors, organ cells live in the feeder bioreactors. The organ cells in there produce the growth factors in situ, and which end up as a cultured serum to flow into the target cell bioreactor. So the target cell bioreactor is most likely meat cells, but it could be anything. We have tested the effectiveness of cell cultured serum, and what we have found is that it is now even more effective than fetal bovine serum, the traditional source of growth factors and other serum components. We have also found that feeder cells can stay active for a very long time. So what would happen is that once the feeder cells are planted in the feeder bioreactors, it can just stay there while the product bioreactor can be grown to full and refreshed with new seed cells to grow into meat again. So here's a graphic of what exactly happens in this CulNet system. So on the left bottom, we have a palette of feeder bioreactors, and on the top right, you see the target cell bioreactor. So at a certain combination of feeder cells, you get a conditioned medium that lets the target cells to proliferate. Then you change the combination of feeder cells. Now you have a different combination medium, which makes the cells grow to bigger sizes. Then further another combination to let the cells organize themselves into meat. So this way, the CulNet system is not just for cell proliferation, but can also do proliferation, differentiation, and organization, all by changing the combination of feeder cells. So we have looked into what's exactly in the conditioned medium produced by the palette of feeder cells. So as far as we've analyzed, as expected, different feeder cell combination produced a conditioned medium with different growth factor composition. And the difference in composition was much bigger than we initially thought. So you see these 25 different feeder cell combinations, and you can see on the right hand side that the composition or concentration of each growth factors is quite different. So, if we are to do something to the target cells, if we are to do something about the target cells, we culturing a lamb or like tiger or whatever, are we proliferating the cell or differentiating the cell? We just set the target. Then we test the library of feeder cells. It's not going to be in millions of combinations, but it's not. It's in the hundreds to thousands, so it's still manageable. And we just do empirical brute force to find the best combination. So it's no magic; it's just the empirical brute force. And at the end, what we get is a system. What we get is a CulCulture system that feeds on basal medium only. So the input is this food grade equivalent of DMEM basal medium, and we call it IMEM, put into the CulNet system. And what comes out is the cells of any type of, what comes out is the cells. So and more importantly, the target cells could be cells of any type of any species, primary or immortalized. That's also true for the feeder cells, actually. So the feeder cells could be primary, but it could also be immortalized. Immortalized cells could have could have higher performance, but it may have its own drawback on consumer acceptance. But that's a different story. So this CulNet system technology originally came from the DIY experiments at the Shojinmi project, in which sports drinks like Gatorade has been used as a cell culture medium. So in this experiment, we have tested different brands of sports drinks to test the effectiveness at cell culture. And we have found that one of them is actually good at it. Then there was also an experiment on CulCulture, in which case this placental cells were used to culture liver cells. And this is how this CulCulture approach was basically our answer to the questions from the New Harvest in 2020 conference titled "The Elephant in the Room." So we saw an elephant in the fact that are we eating cancer cells grown in hormones? So that was our answer. But this technology needs to scale to turn into a real viable solution for the food problem. So the IntegriCulture company has teamed up with experts in scaling of chemical and biological processes. And some of the companies here used to do petrochemical complexes. And obviously, as we decarbonize, the future of such industry is uncertain. So they have a good reason to get into cellular agriculture. And we have built this pilot commercial scale CulNet system, which provides sufficient cultured serum for about 2,000-liter bioreactor. And it's quite common that what works at the laboratory scale does not always work at industrial scale. We are fully aware of that. So we have tested this scaled system and demonstrated that it does actually work even at this 100-liter scale. And so this is demonstrated for chicken and duck liver cells. So if you look at this from a cost or economics perspective, what the CulNet system is doing is it's providing growth factors at a low cost, and the cost compares against recombinants or plant extracts like this. So I'm not fully knowledgeable about the exact cost of recombinants and plant extracts, but we have a figure for the CulNet system, which is mostly based on the capital expenditure. And the figure here is based on a custom-built machine we have right now. So as we standardize the manufacturing of the CulNet system, it will come much cheaper. So the state of the development of the CulNet system, that's a whole schematic. We now have this scaled CulNet system for the feeder bioreactor. Then, and what we need to do is the target cell bioreactor. But for this, we could just hook it up to existing large bioreactor already available on the market. And quite likely, a lot of the cellular agriculture companies already have this. So we could just hook up the scaled CulNet system at any time. But so once the technology is there, what kind of things are we seeing? Is that going to be gigantic centralization or some sort of the ubiquitous distribution where small bioreactors in each restaurant so what's happening right now with within the cellular agriculture industry is that a lot of the startups are engaging in vertical integration, which basically starts from acquisition of growth media materials, and that's made into a proprietary growth medium on which large-scale cell culture is performed, and goes all the way to consumer branding. So when a cellular agriculture startup in this way is successful, it adds just another brand to a supermarket shelf. But to be honest, I don't think it's good enough to solve the world's food problem. We probably need hundreds of thousands or perhaps tens of thousands of cellular agriculture brands going into the supermarket shelves. So that is what we are trying to do with the CulNet system. So this CulNet system, through a joint R&D program called the CulNet Pipeline, is provided to a whole range of players on the market. That could be cellular agriculture startups, or traditional fish and meat companies, or perhaps CPG food companies. Down the road, the CulNet system could be used to not just food, but for materials like fur and leather, cosmetics, or could be for biopharma. And the players using the CulNet system could be farmers, restaurant chefs, or local companies, or could be even DIY hobbyists. So that is basically the vision that was originally drawn at the Shojin Meat project on the DIY cell culture and low-cost cell cultured meat becoming ubiquitous. And that is basically what this universally accessible cellular agriculture and rapid rollout of Cellular means. And in this kind of world where Cellular is ubiquitous, what could happen is that a farmer could develop develop its own cell culture, own design of cell cultured meat using the cow they have. Then what they could do is to basically license the cell and the cell culture protocols to big food companies, and they can and the brand ownership could the farmer could basically get the brand ownership opportunities. The same could be done by restaurant chefs or even hobbyists as well. So in which case, what could happen is this kind of tasty culinary pop star cow. So in this business model, basically the farmer the farmer puts one of their cows into the talent agency which works on the brand development, and the farmer could sell the cell cultured meat, or perhaps ask the license to sell to the food company. So in this case, a cow would worth more alive than dead, because the alive cow will be probably more effective for brand development and to capture fame. So this is another illustration of such cow, but in a very heavily urbanized environment. So this is probably somewhere around the 100th or the 150th floor of an urban center. There's a very small farm with cell extraction facility and cell culture tanks on the back. So back to the CulNet system, where we are is that the scaled CulNet system is already demonstrated for avian species, more precisely for chicken muscle cells and duck liver cells. So this the sample is coming sample for cell cultured foie gras on summer 2022, and it will hit the restaurant in end of this year. And at the same time, we are also semi-finalists of X Prize Feed the Next Billion competition. So the interim documents already submitted, and we are preparing a bigger sample towards summer and fall. And for this scaled CulNet system, the cell cultured serum produced is already available for shipment and testing. So it will be shipped frozen. So if anyone's interested in using this cell cultured serum for avian species, you could try out. And beyond avian species, we have plans to expand, to apply the same principle to different species like bovine, porcine, and seafood. And we're also working on other cell types like adipocytes, fibroblasts, and others. But the CulNet system is not just about cell proliferation or differentiation organization. It could have further add-ons such as cell cultured immunity, and on the basal medium side, there's an ongoing research project on microalgae hydrolyzed basal medium, which would achieve the lowest carbon footprint for production of basal medium, which could happen in thousands to even the millions of tons in the future if cell cultured meat is to go mainstream. And at the same time, microalgae could be used for other purposes, like for regeneration of spent culture medium that would be probably high in lactates and ammonia. So these lactates and ammonia is bad for cell culture, but good for microalgae culture. So there will be a symbiosis there. But at the end, what we probably want, the holy grail of cell cultured meat, is probably a cell cultured steak meat. But obviously, we don't know exactly how to make cell cultured steak meat. So to make structured meat, what we need is very effective oxygen transport, or otherwise the cells in the middle of a cell mass would die. But for oxygen transport, we need proper vascularization to happen. But for vascularization to happen, we need red blood cells. It's kind of interesting that blood, conventional real blood with red blood cells is actually 40 times more effective at oxygen transport compared to just the basal medium. So there, the CulNet system can help because it can also culture red blood cell precursor cells, erythrocytes. So our plan is basically use the CulNet system to produce cultured blood to make the vascularization happen, and that can that then supports the structural growth of 3D muscle tissues. Then we have this tissue cultured whole tissue cultured steak meat. So that's where that's our direction. And as a wrap up, here's a summary. So the growth factor conundrum can be solved by the CulNet system, which converts basal medium into cells of any types of any species. And the rapid rollout of cell agriculture is a highly accessible enabling technology. So we are making this CulNet system such technology. And with such technology, users would gain novel brand ownership opportunities and a whole range of other interesting things they could do. So if you're interested in doing something with the CulNet system and playing around with it, or trying new food, trying to solve the growth factor problem, then contact us at any moment. Thank you very much for listening.